Today we're going to begin our lesson on solving two-step equations. So far we've learned how to solve one-step equations, but we haven't taken any looks at equations that contain more than one operation to undo. So we're going to start with a quick review of equations. So let's get right into this. When we did our first lesson on one-step equations, we did addition and subtraction equations. So we were looking at equations that looked like this. And we were looking at equations that looked like this. And then the next day we did equations that looked like this. And equations that looked like this. And we were practicing using the addition, subtraction, division, and multiplication properties of equality, where I know that in order to solve this first equation right here, I would subtract 8 from each side, giving me x equals 4. The second equation over here, I could add 3 to each side, giving me x equals 17. This next equation, I could divide by 2 on each side, giving me x equals 8. And this last equation over here, I could multiply by 5 on each side, giving me that x equals 15. Well, today, we're going to be looking at two-step equations, such as 2x plus 3 equals 9. Notice as where before this would have been x plus 3 equals 9, now we actually have an additional operation on the x, which is 2 times x. So whenever we look at two-step equations, we know that they have two different operations. And for example, with this 2x plus 3 equals 9, and we're going to go over the actual order of how I would undo all of this, the first thing we would do would be to write the equation. The next thing would be to undo the addition by subtracting on each side, so we'd subtract 3. Then we'd undo the multiplication by dividing by 2 on each side. We'd get a final answer of x equals to 3. So that's the gist of how we would solve a two-step equation. So to solve two-step equations, the first thing, this is what we want to write down now, is to always undo the addition or subtraction first. The last thing is to undo the multiplication or division last. So remember PEMDAS, our order of operations? Now you could think of it as SADMEP. In that last example of 2x plus 3 equals 9, I had addition to undo, and I had multiplication to undo. So with a two-step equation, we always undo in backwards order of operation, meaning I would undo the addition first, then I would undo the multiplication to solve the problem. So again, let's look through that same example. In this case, I see addition and I see multiplication. I'm adding 3 and I'm multiplying 2. So in order to undo what's being done, the first thing I'm going to do is undo my addition by subtracting 3 on each side. That leaves me with 2x equals 6. Then I undo my multiplication by dividing by 2 on each side, which gives me that x is equal to 3, which is what we had on that last slide right there. Alright, so let's try this. Let's solve the equation 6 plus 5y equals 26. Okay, so I'm going to actually use the commutative property of addition to rewrite this problem. 5y plus 6 equals 26. Since both of these are positive and since they're separated by a plus sign, I could use the commutative property and switch those two terms around. I'm going to remember my backwards order of operations, which is SADMEP. I look at my equation and I see that there is addition going on, plus 6, and multiplication going on, 5y. So the first thing I need to do is undo the addition. I'm going to do that by subtracting 6 on each side. I get 5y equals 20. Now I want to undo the multiplication. I'm going to do that by dividing by 5 on each side, which will give me a final answer of y equals to 4. So if I want to check my answer, all I have to do is to plug that 4 back in and see if it works. So I know it was 6 plus 5 multiplied by whatever y is, so in our case that's 4. And we know that's going to be 6 plus 20, which is 26, which is indeed what we said it was, so we know that we got the right answer. Okay, let's try another example. Negative 3c plus 9 equals 3. At this point, I think it would be a really good idea for you to pause the video and try this one without me. And let's see how you did. So again, I want to start undoing by going in backwards order of operations. So I know I see addition here, and I know I see multiplication here. So the first thing I want to do is undo that addition. So plus 9, to undo that, we're going to use the subtraction property of equality. We're going to subtract 9 from each side. That'll leave us with negative 3c equals, and here we're going to have to remember our sign rules. We have 3 minus 9, that's actually negative 6. Then I need to undo my multiplication, so since I have negative 3 multiplied by c, I'm going to divide by negative 3 on each side using that division property of equality. That'll give me c equals positive 2, because a negative divided by a negative is always a positive. Again, if I were to check my answer, that's negative 3 times positive 2 plus 9. That's negative 6 plus 9, which indeed is positive 3. So we know we got the right answer. All right, let's try this 2 more times before we get to the problem of the day. So in this case, I have 0 is equal to 6 plus 1/3 t. Well, I look at this problem, and it's not written in the order that I'm accustomed to, but you know what? I'm not going to let that bother me this time. I could use the commutative property, I could rewrite it, but if I look at SADMAP, since that 6 is positive, I know I'm using addition, or I'm trying to undo addition, and since I'm looking at a 1/3, I'm actually going to consider that 1/3 to be division, because I know that 1/3 multiplied by t is the same thing as t over 3. So I know in order to undo that, I'd actually have to multiply on each side. So that's actually division that I'm undoing. So I'm going to undo my addition first by subtracting by 6 on each side. 0 minus 6 is negative 6. And they're going to cancel out on this side, leaving me 1/3 t, or t over 3. Now I want to undo that division. I'm going to do that by multiplying by 3 on each side. 3's will cancel out. 3 multiplied by negative 6 is negative 18. T equals negative 18, and I'm done. All right, last example. 2x minus 8 is equal to negative 20. So again, I want a SADMAP, and you guys just had a preview of the pod just there when I switched slides. So I want to undo SADMAP here. So I have subtraction this time, and I have multiplication. Good time to pause the video and see if you can work ahead of me. So to undo the subtraction, I'm going to add 8 to each side. So that's going to leave me with 2x is equal to negative 12. Divide by 2 on each side. It's going to give me x is equal to negative 6. All right, that bell signifies the start of the day. There we go. We've got x is equal to negative 6. We've solved this problem. Let's take a look at our problem of the day. This time our problem of the day does contain decimals, but they should work out nicely. Be ready to volunteer to put these up on the board tomorrow, and I'll see you tomorrow. Have a good night.